Hi everyone, welcome to today's Safety and Health webcast, Welding Safety, Insight from the Inside, sponsored by Miller Electric. My name is Kevin Drewley. I'm an associate editor with Safety and Health magazine, and I will be moderating today's session. Thanks for joining us. In a few minutes, we'll start the presentation, but first I want to go over some preliminary items. The views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left hand of your screen and click the button for Submit Question. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. For basic troubleshooting information, click the Help button located on your screen. At the end of the webcast, you'll be asked to complete a brief evaluation survey. I will let you know more about that after the presentation. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speakers today will be Nishank Patel and Sam Harvey. Nishank recently transitioned from mechanical engineer for Miller Welding and Safety and Health to safety sales specialist for the organization. Sam is a product manager with the Welding Safety and Health team, overseeing the head and face PPE category for both Miller and Hobart welding products. Again, thanks to all of you for tuning into this presentation. Nishank and Sam, whenever you're ready, go ahead and take it away.
Hi everybody, this is Sam Harvey from Miller. Before I get started, I'd like to read our own disclaimer as well. So as every welding environment is different and needs to be evaluated by a qualified industrial hygienist to determine the appropriate course of action for fume controls. This presentation is intended for awareness and introductory purposes only and should not be used to replace professional consultation. And then as this group of professionals knows, perhaps more than any other group of professionals, you should read the manuals prior to operating welding equipment in order to fully understand the risk of welding. With that out of the way, so the title of today's presentation is Insight from the Inside. And our goal here is to give you feedback that we've heard from customers that we've visited. So of course, as a company, Miller Electric visits quite a few large end users. And what we're trying here is to give you some of the items that we've learned. So of course we've done third-party research. However, I want to stress that this presentation is not a scientifically researched PowerPoint. It's not based on sample sizes or statistical analysis. We are simply sharing voice of the customer research that we've done, with the hope being that you can use some of the takeaways that we provide in order to enhance your facility, in order to just learn for general knowledge. So what we're going to go over, we'll start with going over common welding safety issues we've seen and heard, both from safety managers as well as from welding operators. We'll then touch on some of the solutions to address those welding safety issues. Again, in terms of two different things, we'll talk both about tools that you could potentially implement as well as any behavioral changes that we would recommend. Then lastly, we'll leave you with some best practice ideas in order to increase operator acceptance and compliance. Really, these are things that in order to put those tools or behavioral changes into action that we think give you the best chance of success. So we'll start out with common welding safety issues that are seen by companies like yourself or companies in the welding industry. And when talking about welding safety, it makes sense to start with eye protection. Studies have shown that eye injuries account for roughly 25% of all injury claims by welders, and that 90% of eye injuries could be avoided with proper PPE use. The three eye injuries that we're going to touch on today are welder's flash, debris entering the eye during or after the shift, and then eye strain. So the main causes that we see from eye injuries are improper helmet settings and use, limited visibility and vision impairments, and then misuse of safety glasses. So in terms of improper helmet settings, really that's about not keeping the helmet down. If you're welding in tight spaces, maybe you don't have the proper lens shade. That's kind of what we're talking about. And again, we'll go into solutions in the later part of the PowerPoint. From a limited visibility standpoint, we're talking about either using a low quality lens that makes it harder to see the weld, not cleaning your cover lens, not adequate lighting, for example, and then misuse of safety glasses. That one's pretty basic, but it's a big one that goes into that debris entering the eye, and so we'll touch on some things that you can do there. So moving off of eyes, another common injury that we see has to do with neck strain. This is something that we hear a lot about from operators. Maybe it hasn't turned into an OSHA recordable injury, but in terms of ensuring compliance of wearing PPE, obviously comfort plays a really big role in that. So specifically, the causes that we see are frequent nodding of welding helmets, limited adoption of welding lens technologies, bulky, oversized welding helmets, and then poor posture and no stretching regimen. And again, we'll break down all these in terms of how to attack those. So now I'm going to hand it over to Nishank. He's going to introduce some of the issues that we see from a fume exposure standpoint.
Thank you, Sam. So with fume exposure, there's really three things we tend to see a lot of. A lot of customers will find that they have excess fume generation. They'll find that their fume extraction arms are not capturing enough fume. And then they might also have, they might be misusing their respiratory protection even though they have some in place. And there's really three things that cause this. The first one is that welders are using improper weld settings and they're not trained properly, right? So if you don't have the right welding parameters, you could have lots of spatter and fume generation. So that's one of the big things that we see is that people are not trained properly. They are not using the right settings. Next, there is operators, they're not adjusting their extraction arms. So with fume extraction arms, usually the normal capture distance is roughly 1.5 times the width of your opening of your hood. So it's a pretty narrow window, and let's say you're working on a long weldment, and all of a sudden you're further away from your extraction hood. You really need to keep moving that arm to make sure it's positioned properly so that it can capture the fume. And welders tend to, sometimes they might be lazy and they might not do that. So that's one thing to keep an eye on. And then finally, it's like Sam said, it's acceptance, right? You're wearing safety equipment. Comfort's a big deal, especially with respiratory, and you're wearing PAPR systems or supplied air systems. It's the neck strain issue. People can be claustrophobic. They can't talk to people. So it takes time, but a lot of it is also training and using the product correctly. So next, I want to cover hand injuries. The most common thing we see with hand injuries are hot wire pokes. And again, there are three things that we tend to see that are causing them. Number one is improper welding glove selection. So basically, depending on what you're doing, whether it's stick, MIG, or TIG, you always have a trade-off between having the dexterity in the glove and the padding in the glove. So you want to make sure that, let's say you're doing stick welding, for example, and especially the higher amperage you're using, you want to move to a heavier duty glove, right? So that's the first thing we see. Then we also see when you're doing really small welds, so you're tack welding or you're moving really quickly, that's, welders are not paying attention. That's another place where we tend to see a lot of these injuries. And then finally, it's just the torch angle and position and having that set properly. That can make a big difference. So those are some three things we see with hand injuries. And now I'm going to turn it back to Sam to talk about solutions and what we can do to avoid all these injuries we just mentioned.
Great. Yeah, thanks, Nishank. So heading into solutions, we'll head back to eye injuries and start with welder's flash. So as a lot of you might know, welder's flash occurs when harmful ultraviolet rays are absorbed by the cornea. It can be very painful. It's not usually permanent, but it can be. But mostly it's very painful, and it leads to eye swelling and tearing. From our standpoint, the best way to prevent welder's flash is to keep the hood down. Even if an auto-darkening lens doesn't darken for some reason, the welder is still 100% protected from ultraviolet and infrared rays. So welder's flash does not occur with the hood down. Now, there's a lot of different ways to try and increase the percentage of time that your welders keep their hoods down. The ones that we see the most are comfort. So I talked about that earlier on in terms of how important it is to purchase products that are comfortable. We see this as a win-win for the operators and safety managers in the sense that it's easier to drive adoption, and of course it leads to more compliance. Another thing that we look at in terms of keeping the hood down would be newer lenses that are out on the market that provide greater clarity while welding. So obviously it's important to have increased contrast when you're welding, but in terms of reducing welder's flash, having a lighter light state makes it so that you can keep your hood down even when you're not welding. In terms of outside of keeping the hood down, providing tools for unique applications. So we've heard too many times of people trying to weld in tight spaces who need to quick take their hood off and just cover their eyes with their arms or use some other type of method that we would say is not compliant. But really it's because they can't fit their helmet in. Either they're welding underneath a chassis, or they're trying to get into this tight confined space. There are now auto darkening tools available so that people can weld in tight spaces that fit very close to the face, and so we don't really see a reason for not equipping welders with those tools. Moving on to debris. I really don't have any groundbreaking or earth-shattering insight here in terms of how to prevent debris from getting into your eye. It really has to do with the basics. So in terms of primary eye protection, ANSI does recommend that we wear primary eye protection under secondary protection. Primary would be like a safety glass. Secondary is your welding helmet. So we always tell people that they should be wearing safety glasses underneath a welding helmet. And if you think about it, well, that safety glass may not necessarily be doing much while the welding helmet is down. It still might, but really it's playing a key role when the welder raises up their hood. And so a lot of times you hear about how tiny little metal shards will fall into somebody's eye after a weld when they raise up their hood, or maybe they're leaving for the day. Those are really times that you don't necessarily think about protection, but that lead to pretty terrible things getting into people's eyes. Second, keeping your eye protection in good condition. Of course, if what you're wearing prohibits you from doing your job as well as you can, it makes your experience less enjoyable. It's not going to lead to people complying as much as we would like to see. So really easy stuff in terms of cleaning at the end of the shift, or replacing when need be when they get scratched. Just really some of the basics that unfortunately we continue to see in accounts that we go into. So from a strain standpoint, I guess we'll start with the basics again. So providing cheater lenses and replacing dirty lenses. So magnifying lenses or cheating lenses, cheater lenses, those are available in pretty much all welding helmets in terms of you just buy a little piece of plastic that you can slide in front of the inside cover lens. And especially for the older generation, those are pretty useful. So to reduce, the strain of needing to get really close to the weld or trying to focus more than you need to be, definitely provide cheater lenses. They're very inexpensive. Secondly, making sure that your welders are selecting the proper lens shade. Again, this is pretty basic, but there are a lot of new welders entering the industry. What Miller recommends is to start at the darkest shade and then work your way down until you're able to see the weld puddle, and it's a comfortable view. So don't start at shade 8 or shade 9, for example. Start up at shade 13 and then select the right shade so that you can see it. You're not overly straining, but that your eyes are protected and it's comfortable. Next, improve clarity. So I hit on this a little bit, but in terms of buying the latest and greatest, there are quite a few advanced lenses out there that try to make it easier to see the weld puddle. So of course, when you have this increased contrast when you're welding and a lighter light state when you're not welding, it just makes it easier to see, which leads to a reduced eye strain. And then lastly, staying protected at all times. So there are many options out there that have integrated grind shields, which allow welders to keep protection on when they're not welding. So as opposed to lifting up the full welding helmet and only having safety glasses on underneath, this would be where you raise up your auto darkening lens or your passive lens, and you have an integrated grind shield underneath, which is a really big productivity enhancement, but it also is a great safety tool because you're fully covered that entire time, and you can just move on to whatever other task you're going to do, whether it be grinding or prepping. You're fully protected, and your eye isn't straining through a shade 3 or a shade 4 light state. So in terms of improper body positioning and neck straightening, the next thing that we would look at doing is eliminate nodding. So this one is, again, kind of basic, but there is definitely still a lot of passive helmets out in the market, and they certainly play their role. But auto darkening helmets are becoming pretty inexpensive and very reliable, and they really do reduce the need of nodding. Of course, if you're using a passive lens, you keep your hood up until you're all set up and ready to start welding, and then with a jerk of the neck, you lower down the helmet. Over time, this can cause issues for neck. When you hear of welder's neck, typically it comes from that nodding. And so to transition to an auto darkening hood is a very, I would say, inexpensive investment to make in a person's long-term health. So helmet selection, so things to think about when you're choosing a helmet to reduce neck strain. So helmets certainly should be light. You know, people think about that always. The other thing that we talk about would be balance. There's really two variables that go into neck pain when it comes to just selecting a helmet, and it's weight and balance. So you can think about balance in the effect of, do you want more weight hanging off the front of your face, or would you rather have it on the top of your head? And now, those are very drastic, of course, but that just gives you an idea of from a neck pain and a torque standpoint on the back of your neck, it's reduced when the weight of the helmet is shifted towards the back. So when looking at both weight and balance, that's a key component towards neck strain over the long term, and it's amplified when using hard hats. So trying to find a solution where, you know, you obviously have to fit this hard hat underneath your shield now, so the weight of the welding helmet it's pitched up and it's also pitched forward, so that torque equation becomes even more important. And we do see, you know, more neck issues when it comes to hard hats with welding helmets. Lastly, so just kind of physical movement. Now, a lot of times you have to do out of position welding, or even if not, you might be staying in a good posture position. However, you're in a pretty consistent position throughout the day, and that puts a lot of strain on muscles over time. So really a basic thing a company can do is implement, you know, a 5 to 10 minute stretching program, whether that's at the beginning of the shift. At Miller, we do it during a break during the middle of the day. It could be both, depending on how, if you're doing a lot of out of position welding or anything that really strains the neck muscle. Those are things that can go a long way towards building those muscles and releasing some of the strain. Another thing to think about would be job rotation. So that's something that we try and do at Miller Electric when it comes to assembly. It's something that other companies should be implementing as well when possible. But you can kind of think about it if you have certain welds that are at one position, so potentially they're straining certain muscles. If you could rotate that person after a couple of hours to a different piece of work and they're at a different position, it's using different muscles, so it really helps reduce fatigue overall. And then lastly, maybe that was the last one, actually. Oh, sorry, yes. So the last one would have to do with work hardening programs. So thinking about new employees entering the workforce, it's very well documented that welding has an old workforce, or older, I should say, workforce, and there's going to be quite the influx of young people. A lot of times what we see are people getting injured in the first year or two on the job. And, you know, it's not really hard to imagine why. If they're not used to standing for 10 hours a day or 8 hours a day or 12 hours a day, then they're probably not used to standing and being in a certain position. And so when it comes to back, neck, different types of strains, work hardening programs, while not necessarily easy to implement because of potentially the culture, or people who have been there for a long time looking at the new people and wondering why they're working less, they can pay dividends in the sense of reducing the amount of issues that new employees have when they start a job. So before I hand it back to Nishank, we have 2 polls today that we're very excited to ask you to get some participation, also some rapid fire feedback for us from a voice of the customer standpoint. So the first question we have is, which of the below scenarios do you or your business struggle with when welding? And we'd like you to choose all that apply. So you can see the 7 different responses there. I'll read through them quick. Feel free while I'm reading to be doing your response. We'll give about a minute to do this. So the first one has to do with fogging or condensation in the helmet. The next is welding in tight spaces. The third would be collecting welder productivity data. The fourth is welder training or onboarding. Fifth is not enough ambient lighting in the work cell. And then we'll go on to fume management for the 6th one. And then maybe you are awesome. Probably you are awesome. But even if you are, you might have some of these struggles. But the last one would be if you don't have any of the struggles that we have listed. So if you could please choose all that reply, and I'll give another 20 or 30 seconds for everybody to answer before moving on for everybody to see the results. Okay, hopefully that gave everybody enough time. So fume management is the winner, along with welder training and onboarding. Welding in tight spaces following close behind. It is worth noting that 8.7% of you are awesome and don't have any of these struggles. I did put one of those for myself too, just to make sure it wasn't left all alone, but I don't think I was the only one. So congratulations to those other ones who chose item G. For the rest of you, we appreciate that feedback. So now I will hand it off to Nishank to go over some of the things that you can do from a fume exposure standpoint.
Thank you, Sam. So number one thing you can do with fume exposure and how you can combat that is proper training, right? And with proper training, what does that mean? Really, it means that there's really, again, 3 things that you can focus on. You really had to take a look at your process and the parameters you're using. For example, let's say you're doing stick welding. Stick welding is always going to generate more fume than a cleaner process such as MIG welding. And then MIG welding is always going to generate more fume than TIG welding. And again, I said always, but it's generally that's what we tend to see. So depending on what process you're using, if you can change processes to a cleaner process, that's definitely something you can do to help reduce the amount of fume you're generating. Another thing is, for example, it's the transfer type. So when you're welding, whether using short circuit or spray, there is technology out there called pulse welding. And what pulse welding does, it dials in the exact, and basically it gives you the right amount of heat that you need, so you don't produce excess spatter or fume, right? So if you address the welding process itself, you can really dial down on the amount of fume and spatter used. So there's a lot of power sources out there. There's a lot of different kinds of wires, different alloys that they're made with. Take a look at that and make sure that if you can switch, if that's something you're able to do, that will definitely make a huge difference in changing the amount of fume you generate. Besides training and modifying the process, it's also the materials you're welding on, right? So a lot of times, a lot of environments, they're very dirty, right? So you have a lot of dirt, you're grinding. So it's very important to clean your workpiece, right? Make sure your base materials are clean. The wires you're using, there are a lot of wires out there that they're low fume wires, and not only low fume wires, but certain alloys, for example, we know manganese, beryllium, hexyl, chromium. These are all chemicals that are hazardous, right? So there are wires with low concentration of those hazardous substances that you can use. You can also add more argon shielding gas to add stability to your weld. So those are some things you can do to really target the fume generation itself to reduce your exposure. Next, we'll take a look at the arm, right? As I mentioned earlier, there are extraction arms out there, but they only capture 1.5 times the diameter of the hood, right? So, most of us, imagine if you were working on a long weld, it'd be pretty easy to forget to move that arm, right? I would be struggling every time I had to go somewhere. I had to always move the arm with me. That would be a very repetitive and painful process. So you can either make sure that you train your welders to do that, and making sure that they always position the hood an appropriate distance from the weld, and making sure, I know that this sounds silly, but making sure the hood is facing your weld, right? And it's actually pulling the fumes away from the welder. A lot of times you'll see you see all kinds of stuff with that. So it sounds really simple, but that's what it is making sure that you train your welders to make sure that they move that arm. And there are also solutions out there, for example, that we call advanced airflow solutions. Miller has a technology called a Capture 5 system, and instead of the standard 1.5 diameter, which translates to about 12 to 18 feet of capture distance, you can get up to 5 feet of capture distance. So if you think about it, we just talked about the problem where welders they're not moving the arm, they're not putting the arm in the right position. Well, if you increase the capture distance, right, then you don't have to constantly adjust your extraction arm. So keep an eye out for technologies like that, and if you can implement something like that in your facility, then it makes it a lot easier on your welders too, and it helps with your productivity. So, and then the final thing I want to cover on fume exposure is respirator misuse, and we see a lot of this out there. Is people will, they don't like something about their respirator and they'll modify it, or they'll use parts from one manufacturer and put it with another manufacturer, and that's really a big issue because these systems, all these products are tested as a system, right? Anytime you modify them, you could be actually reducing your protection, right? Because they're not intended to be used in that configuration, right? So always try to use your safety equipment, right, or your respirators in the original configuration, or if there is an approved accessory or configuration, then only you can use it. The other thing we see with respirators is making sure you're using the right respirator, right? So there's different hazards and different exposure ranges. So for example, if you're dealing with vapors, gases versus fume particles, so make sure you have the correct type of filter that is rated appropriately for your hazard, right? And then also, depending on your exposure level, there are different levels of protection that different respirators provide, right? For example, you can start all the way on the bottom with a disposable dust respirator. You can move, and then you can go all the way up to PAP or supplied air systems, and all of these solutions will have an assigned protection factor, and you need to make sure that the assigned protection factor you're using matches up with your exposure levels, right? So, and like I said, exposure level. There we go. The other thing with respirators is modularity, right? So oftentimes you'll find environments where, if you're somewhere really warm, and let's say you're using a PAPR system, which is a battery operated system, your welders might be saying, hey, can we get some more colder air in here? So you could potentially look at a supplied air system. And so if you have solutions that are modular, right, it can really save you a lot of money, because you think about it, if you have a head assembly, if you use different solutions, you got a different head assembly for each respirator. That's a lot of cost, right? So try to look for solutions that are modular, that you can easily swap out. We talked about, we don't want you you shouldn't be mixing solutions from different manufacturers, right? So try to find manufacturers who have modular solutions. The other thing is really consider the welder's needs, right? At the end of the day, none of us like wearing uncomfortable clothing, right? If you're in Texas in the summer, none of us want to wear a winter coat, right? So think of it that way. No one wants to wear a leather jacket and when it's really warm. Same way with helmets. It takes time, right? Especially with these respirators. So try to do things like, if your welders constantly had to switch between a grinding helmet and a welding helmet, there are integrated grind weld helmets out there that can really take all the discomfort, all the monotony of constantly doing different things that interrupt your productivity, that can really increase that welder acceptance rate. Because if your welder's not happy with it, he's not going to be using. The chances are he might not be using it properly. So I hope that covers a little bit about the respirator. Before we move forward into talking about hand injuries, I want to do a quick poll question. And I think this is the last poll question. The question is, which of the below reasons lead your operators to not using their respirators correctly? So option 1 is obviously discomfort. Option 2, welders don't feel the respirators are needed. Option 3 is interference with productivity. Option D is they do not work well with your other PPE. For example, you could be wearing a helmet with earplugs, safety glasses, things like that. E, if you got amazing welders and they, you have no issues, then none of the above. And then F, if you don't use respirators, then you choose that solution. So I'll give you guys a minute to answer, and then we'll take a look at the poll results. So let's take a look at the answers. So the most common one we see is that operators feel that respirators aren't needed or they're uncomfortable. And really, as we talked through the slides, we talked about how acceptance is the biggest thing. And that's kind of what we see here. And the biggest thing, again, like we said, is it's training, right? Is making sure the welders are using the equipment properly, they understand why they're using it, what the harmful effects what the harmful effects of all these substances are. So it's that training and education piece can really increase the acceptance of the respirators. Let's quickly go over the hand injuries and what we do with hot wire pokes. So we mentioned earlier that we need to be using the right glove. And what does that mean? So there are gloves out there with thicker materials for more heavy-duty welding. If you're doing higher amperages, it depends on the type of welding you're doing. Try to look for those gloves with more protection, right? And then try to see if they have Kevlar lining. Those kind of things can really help with those hot wire pokes. And really start with an application assessment, right? Ask yourself, what is the right type of glove I need to be using for this application, right? If you have a safety specialist that you're working with, really try to engage them on the different type of gloves, different manufacturers offer, and try to make sure you select the right one. And then, and a lot of it again comes. I know we're repeating this, but a lot of it comes down to training and awareness. Are you positioning your body? Is the body positioning right? You have new welders coming into your facility, and as Sam said, most of them tend to get injured in the first 2 years, right? So can you share best practices with them? Do this, don't do that. Things like that. Those little things, they go a long way in helping avoiding injuries. And some of the stuff we see, it can, like Sam said, a lot of the injuries are easily avoidable if only people had the right training, right? Again, it's same right settings, things like that. So what I want to do now is turn it back over to Sam to talk about how do we implement these solutions.
Great. So thanks for hanging with us so far. So in terms of best practices when you're implementing changes, the first thing I always like to start with is transparency. I mean, in terms of trying to drive change within a facility, if you're not upfront with why the change is occurring, what's going to happen, what's really the vision behind it, you're not going to be very successful. It's totally natural for humans to be resistant, perhaps even cynical if they're not sure why their surroundings are changing and why people are telling them to do something differently. So we always recommend to be really transparent with what you're trying to accomplish and why. Secondly, so engage people. So don't just be transparent, but empower your employees, empower the supervisors. This should not be a top-down type of initiative. Like, yes, the strategy might be top-down, the awareness, the investment certainly, but when it comes to getting people to adopt a new type of PPE or adopt a new type of process like a stretching regimen, those are things that you want to be kind of led by the people who will be doing them. So consider appointing a steering committee, having perhaps a line supervisor take on the responsibility of trying to drive the adoption. And then lastly, so getting feedback. So it's a pretty small chance that you're going to get a change 100% right away. So having channels that are open so that people can give feedback, and then most importantly, either acting on the feedback that you get in terms of what's not going well, or at the very least just giving a response in terms of, no, this is why we're going to continue down the path that we've taken, or no, this is why we're not going to make that investment. Don't just leave those comments in the shop floor box unanswered. Otherwise, that's how you lose the empowerment. And again, in order to have that empowerment and adoption, I think it's really important to give feedback to people once they try and give you their feedback. So the first one that I just went over was collaborative. So be collaborative. Secondarily, so think about productivity implications. Whenever you're making a change on the shop floor or wherever you are, you're doing something different. It's going to take a little bit of time. There might be a learning curve. Again, from an operator acceptance standpoint, it might not be there right away. One thing that I would just say based on our experience is to increase the chance of operator acceptance, have it not impact productivity, of course, but that doesn't always work. So that would be another thing to be upfront with. If you expect productivity to go down a little bit as people are getting used to something, be encouraging about it. Perhaps you need to get with your operations team to make some changes, whether from an overtime standpoint, from a staffing standpoint. You want to be supportive and give yourself the best chance. And if people see that their productivity is being impacted because you told them to do this new thing, and now they're not able to do their job as quickly as they're used to, they're going to become cynical pretty quickly. So if you expect productivity to be impacted negatively, be prepared to counteract that. And then, of course, hopefully when you're doing some of these investments or changes that we've talked about, productivity might be positively impacted, in which case that'll help drive operator acceptance. And that's something that you should help celebrate to reinforce the changes. So next, be patient and confident that long-term results will come even if there's a learning curve. And then, as I mentioned a little bit ago, so potentially if the scope is large in terms of the change, you might need to adjust production for a short period of time, or otherwise change your operations so that you're more successful. So consult with like companies. Doing stuff like this is really good, of course, because you're learning from other companies. But perhaps more specifically in your field, if somebody's good at safety, I hope that they're willing to share. I mean, this isn't quite like a productivity thing or a unique process. Everybody wants their employees to go home in the same state that they came to work. That's our top goal here at Miller Electric. And if there's things that we can do to help our fellow companies in the welding industry, we'd be happy to help from a safety standpoint. But we do encourage others to reach out and see what best practices they can take from other companies instead of reinventing the wheel. And I'll hand it back to Nishek one last time for him to take us home.
So we talked a lot about problems, solutions, how do you implement it. What I kind of want to touch up, what I want to end with, and what I want to kind of touch on is what can you do? How do you go about identifying the problem and solving it? What does that process look like? So normally, you start with you analyze your work environment, right? Try to see what kind of hazards you have and identify them. Then you wanna obviously document those, right? You want to write down, hey, these are the kind of the issues I've been having, collect them, and then finally you want to engage a QSSP certified safety specialist. And I say QSSP because that's the kind of training a lot that the safety specialists go through to really identify what kind of hazards you're dealing with, right? And when you come in with all that work, when you do all that work ahead of time before engaging that safety specialist, where you know what your issues are, you're documenting them, then you can really leverage the knowledge of that safety specialist to have them tell you and work with you on finding the right solution, right? Because they don't know your work environment. You know your work environment better than they do. So the more prepared you are going into it, the more you'll get out of it. Next, you'll work together to determine what is causing those issues, right? Let's say your hazard, you're having a lot of fume issues, right? They'll find the source of that fume issues. It could be the process. It could be respirator misuse. It could be you're not moving your extraction arm properly. So those are kind of things that you'll kind of look through together and try to find out what the root cause of that problem is. And then as you work with them, right, you'll observe it, and then you'll elevate visibility of the issue, right? So once you make your hypothesis that, hey, we think that most of our fume issues are coming from, let's say, or welders are not moving their extraction arm properly, try to observe and validate that hypothesis, right? Before you move into looking into solutions, try to make sure that you actually have the root cause of what is causing the problem. Because if you just bring in any solution in there and you don't nail down on the root cause, it will not work properly. Or you could tell, for example, let's using fume extractors and it's the arm that is not being moved properly, and then you make your welder to wear respirators, which they don't really want to do. Well, the problem in the first place was moving that extraction arm properly, right? So could you look at different technologies where you don't have to move that arm as much? So it's really important to identify, have your hypothesis on what the issue is, but then also observe and make sure you confirm it. And then the final step is committing to safety, right? Is working with a safety specialist. You identify what the right solution is, and then you really work with them to implement that solution. And you get participation from all your employees. You educate. We touched on training and why it is so important to train your welders. We did that poll question where the number one thing, the problem was that welders they didn't think they needed to use the respirator, right? So it's getting that participation and engagement from them, And then it's developing an action plan. Like, so for example, when you do respiratory protection, you will need to do a written respiratory program, right? That you'll need to put in writing, and you'll need to say, hey, what different kind of things are we going to be doing? It's not just I'm not just going to buy this respirator and that's going to make all my problems go away, right? It doesn't work like that. You gotta do training. You gotta make sure you maintain the equipment and all those kind of things. So I know this process can be scary and confusing, but it's really simple, right? It's try to understand what your issue is, make sure you validate that is your issue, and then you pick a solution that meets the specific needs of your environment, and then you make a plan around it where you're getting engagement from your employees. So I know we covered a lot, but I hope that was helpful and kind of just, as you can see, those are some of the things that we run into a lot with customers and different organizations in their facilities. So at this point, I think I'm going to turn it over to Kevin to go through the questions.
All right, excellent. Great job, guys. Thanks for your insights and expertise. Before we do start the Q&A, I just want to remind everyone of the evaluation survey that we're asking you to complete. The survey should be appearing on your screen now. Your input is important because it'll help us improve future webcasts. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. And with that, we'll get to some questions. We're going, just so everyone dialing in knows, we're going to alternate between Sam and Nishank. So first one here goes to Sam, and that is the auto darkening lenses utilizing the similar technology? Are those like transition eyewear?
Yeah, so just so that everybody's clear, so transition eyewear, so transition lenses are where their glasses are clear indoors and then they darken when they're exposed to sun when you go outside. So what those do is when those glasses, the lenses, are exposed to ultraviolet rays and sunlight, a chemical reaction actually changes the properties of the lens and it absorbs some of the light. So that is very different than what auto-darkening lenses do in welding helmets. And I won't go super in-depth, but just from a high-level standpoint, from an auto-darkening lens, what you have is you have a welding filter, which absorbs the ultraviolet and the infrared rays, the harmful rays, and that's always working, that's always there, which is why earlier in the talk I mentioned how even if your lens doesn't darken, you're protected from UV and IR rays. The welding filter is what will kind of create a discoloration, so you probably are used to seeing a yellow-green tint. After the welding filter, you have a set of LCD panels, and those are actually what trigger when you start welding, and they're triggered by arc sensors. So one of the things that you'll notice if you're purchasing a welding helmet that's auto-darkening is it'll say that it has 2, 3, or 4 arc sensors, and that just tells you the more sensors the better, because the better chance that it's going to pick up the arc. But basically those arc sensors immediately darken the LCDs once they pick up the bright light. And typically it's about 1/15,000th of a second or 1/20,000th of a second, so it's something that's not even noticeable to the eye. The last thing I'll add in here is that there is a different type of sensing which closes the lens, and that's called X mode when it comes to Miller Electric. That's a trademark name. So X mode is when instead of just relying on the arc sensors to keep the lens closed, it actually relies on the electromagnetic field of the weld. And we put this into some of our higher end helmets so that if you're welding out of position, potentially the arc is going to be blocked and you don't want your lens to open up. Or if you're welding in sunlight and you don't want your lens to darken when it shouldn't, you would just put your helmet into X mode or into any electromagnetic field mode, and that way it will work properly. So that is how an auto-darkening lens happens. Hopefully I answered that one.
Okay, next one goes to Nishank. How do I know if there's a fume problem in my welding operations?
Excellent question, Kevin. So, the first step, what we talked about, is analyzing your environment, right? And with fume generation can be a natural process. It's a natural process of welding, right? The thing you really got to make sure is you got to look out for the hazardous chemicals, right? Is if you're doing things like you're working with hexyl chromium, manganese, beryllium, really want to partner with an industrial hygienist to do air sampling, right? You want to understand what is the concentration of those particles in my air, and is it at safe levels, right? And if it is at safe levels, you're good. But if you're not at safe levels, that's how you know you have a problem, and that's how you know you how to implement a solution. So.
Okay. Next question, Sam again. How do I troubleshoot if an AD lens isn't working properly?
So if your auto darkening lens isn't working properly, the first thing that we recommend doing is changing out the battery. And if you're using a Miller-specific lens, we have a specific battery that we recommend people use, and so you want to make sure that you're using the correct battery. There's some differences in terms of the shoulder height of the battery, which can cause improper contact, so the lens won't work properly. But then, depending on the lens that you have, you can do a hard reset once you put in the new battery, and you should see the lens flicker on. Most of the different lenses or helmets that you purchase will have the same type of reset. Just look in the manual for how to do it. Assuming that you see that reaction, you'll know that your lens is now working properly. So that would be kind of, if your lens is just being non-reactive. If perhaps it's opening up when it shouldn't, you're welding and perhaps it's low amperage, so there's not as much light and your lens is opening up, you would just want to adjust the sensitivity. And so the higher sensitivity that you have, the more responsive those arc sensors will be to the light. Another thing you can look to adjust if your lens isn't acting as how you would prefer would be the delay setting. And so that's something where potentially you're doing pulse welding, or you're doing a type of weld where the lens is going to open up because the arc goes away for a brief second, and then your lens might think that you're done welding. So in order to change that, you can increase the delay so that it doesn't open up for up to a full second. So there's different things from the settings that you can do. If your lens is totally turned off and won't turn on, then it might be a battery issue. Otherwise, keep in mind that these things are subjected to quite a range of temperatures and sometimes a beating depending on the welder. So stuff can happen to lenses over time, but that's how we would troubleshoot.
Back to Nishank. Would it be safe to say that all types of welding require some type of respiratory protection?
I wouldn't say that, Kevin. I think it really boils down to, like I said, you need to really understand what your fume levels are, right? And understanding only when you're above those exposure levels, right? The limits of those exposure levels, that's when you have a fume problem. So, I mean, if you're doing stick welding, for example, you're always going to get fume out of it, and a lot of that is natural. It's making sure the concentration of those harmful particles isn't above the minimum amount, right? That's when it becomes hazardous and dangerous, and that's when you need to implement solutions.
Okay, thank you. Sam, this one's a question and asking for a clarification. Did you say that 25% of eye injuries are from e-welder? Or I think it's looking for clarification of what 25%.
Yeah. Yep. No, I get it. Thank you, Kevin. So that's good. I definitely want to clarify whenever we throw out stats like that. So what I was trying to say is that 25% of welding injuries are eye-related. And so where that came from, BMJ Journals, which is formerly known as the British Medical Journal, probably a more recognizable name. So they did a study a while ago that looked at total injuries within different industries, and found that 5% of injuries were eye-related overall. When looking at just the welding industry sample, it was 25%. So really, we're just highlighting the higher risk of eye injuries that welders are subjected to.
All right. Nishank, what elements should I look for in a respirator to ensure my welders want to use it?
Yeah, and one of the things that Sam touched heavily on is comfort, right? And that's the number one obstacle we see is all of a sudden you're being asked to wear this really heavy respirator device on your head in the scenario you're using a PAP or a supply or a hard hat. And the welders, they really don't want to wear that. So it's really finding manufacturers that make comfortable solutions. So there are a lot of manufacturers out there that really focus on making lighter weight helmets more comfortable. Their airflow is optimized to target the blood vessels, making sure that the airflow you get is cooler. It keeps the welders more comfortable. So things like that really get the welder thinking that, hey, this I feel more comfortable in my welding environment because I'm wearing this respirator device. Those are the things that can really convince them and increase the user acceptance of those devices.
Okay, thank you. Looks like we've got time for one more question, and we'll go to Sam. How do I get the most longevity out of my welding helmet?
Sure, yeah. So I just kind of talked about how potentially welding helmets can be given a rough go depending on who they're using, but most likely it's not the user, it's the application in the industry. I mean, certainly we see a lot of environments that are just tough on a welding helmet because that's just the environment, and that's why welding helmets need to be durable. In terms of how to make it last, so obviously there's the stuff that you can do at the end of your shift in terms of cleaning it off and some of those basic things where you don't want metal shards to get into the mechanical components. You want to try and keep the cover lenses clean so you don't need to replace them all the time. A big thing that we would see is cracked lenses. So I mean, most of the cost is in the actual auto darkening lens, and so if you're throwing it around and it cracks, unfortunately that's something that's not usually warrantyable by companies. We do drop test at Miller in order to make sure that it can fall off of a desk and be fine. But some of the helmets that we see are just pretty banged up, so that would be a key one. Keep in mind it is several panes of glass sandwiched together, and so it's an electrical component. So be careful there, and then I guess clean it at the end of the day would be the other big one that I can think of.
Okay, thank you. Unfortunately, we've run out of time. I'm sorry we did not get to everyone's questions, but all of today's unanswered questions will be forwarded on to today's speakers. Once again, hope you take the time to fill out the evaluation survey on your screen to give us your feedback. And that ends today's Safety and Health Magazine webcast. I'd like to thank Nishank Patel, Sam Harvey, everyone at Miller Electric, and all of you who listened in. Thanks, and have a great day.